AI tools are becoming user-friendly. You do not need to be a computer expert to use them. We will use Google Gemini, Trippo Studio, and optionally Blender and Mixamo. All of these are free apps. There are other apps that do the same things. Microsoft Copilot is similar to Gemini, but Gemini seems to create better images for what we are doing. Meshi is very similar to Trippo Studio, but Trippo Studio seems to create more detailed models. We are going to use two different methods to make the figures. The first method is the simpler one. We will have Gemini create the image in a pose, and then we will run it through Trippo to create the three-dimensional figure. Just for fun, I think we're going to load a picture of a random person. We can call him Seth. Then we are going to ask Gemini to create an image of a railroad worker wearing 1920s clothing using that face. I'll let this run in real time so you can get a sense of how long it takes for Gemini to create an image. It doesn't matter how fast your computer is. The image is being generated on a big server somewhere else. Looks like I forgot to ask it to make a full height body, so the first thing I have to do is make him full height. While we're at it, we can remove the background. I will speed this up so that we don't have to wait for Gemini. Let's remove the lantern and have him raise his left hand as if he's signaling somebody. So here's our figure. We can just download this and open it in Trippo Studio. First, we drag the image into the little upload box. You can't see what I'm doing here because for the video, I'm only capturing the Trippo window, but I'm just dragging the image file from the folder on my computer into this upload window. We are going to change a couple of settings. We set the topology to quad, which gives you a smoother finish, and we change the poly count to 100,000. Going higher doesn't make much difference at the small sizes we print. We have to change the model to 2.5 since we are on the free plan at Trippo, or we won't be able to download the model. We tell Trippo to generate the model. This takes a few minutes. One of the nice features in the paid tiers of Trippo is that you can use images of the front, back, left, and right to generate a model so it doesn't have to guess what the back looks like. The paid tiers use newer AI models, which may be better at guessing what the back looks like. We can speed up the video here. After a few minutes, you get a preview of your model. If we zoom in, you can see that it captured quite a lot of detail. It made a reasonable guess to create the backside. This looks pretty good, so we're going to export it as an STL. There's no reason to use OBJ or 3MF files because they just add textures and things that don't make any difference when we go to print. I can load the STL into Chitubox, my slicer, so that you can see what it looks like. You can see there's a fair amount of detail. It doesn't look quite as much like Seth as it used to, but it's still pretty good. We can set this to S-scale height, since S-scale is the best modeling scale. You can see here what the printed figure is going to look like, so go ahead in 3D, print several copies and paint them, and have Seth all over your layout. The second method involves creating the image in Gemini as usual. For this image, you tell Gemini to create the character in T-pose and to have her fingers spread slightly apart. I also told it to spread her feet a little bit apart. In Trippo, drag the image in, set the topology to triangles instead of quad, and the poly count 100,000. Remember to set the AI model to 2.5 if you are using the free tier. Click Generate Model. For this method, export an OBJ file. We need to rotate the figure, which is very easy to do in Blender, a free program you can download. While we're in Blender, we're going to clean up the OBJ file. This will help prevent rigging and printing failures. This looks like a lot of steps, but it's the same exact steps every time. I put the steps in the comments below this video. After doing these steps a few times, it only takes about 5 minutes for each model. Open Blender and clear the stage by pressing AX and then Enter. Click on File, Import, Wavefront OBJ. In the import window, set the scale to 100, and if the clamp is not already set to 0, set it to 0, locate your OBJ file, then click the Import button. Blender likes to smooth out figures, which causes a loss of detail, so we're going to tell it not to do that. Click on the little green triangle at the right side of the screen, click on Geometry Data, and then click on Clear Custom Normals Data to turn it off. Right-click on your model and select Shade Flat. Left-click on the figure and then in the top menu, select Object, Apply All Transforms. This just cleans things up for a good start. Change the mode to Edit mode. Now we're going to fix any defects in the OBJ file. In the top menu, click on Select. Select All by Trait, Loose Geometry, then click Mesh, Delete, Vertices. Now in the top menu, click Select, Select All, then Mesh, Merge by Distance. In the top menu, click Select Mesh, Cleanup, Degenerate Dissolve. Next is the most important repair. Click on the viewport off the figure and then go to the top menu and click Select. Select All by Trait, Non-Manifold. Then click Mesh, Delete, Vertices. Click Select, Select All, then Mesh, Normals, Recalculate Outside. Change from Edit mode to Object mode. In the top menu, click View, Viewpoint Front. The character will probably be facing sideways, so press RZ -90, that is RZ-90, and press Enter so the figure is facing forward. In the top menu, select Object, Apply All Transforms, and then File, Export Wavefront OBJ. Fill in the location and file name and click the Export button. The next step is to rig the figure, which we do in Mixamo. Rigging is like giving the figure a skeleton. Go to Mixamo.com and log in. When it opens, it will show the previous character you worked on. Click on Upload Character and drag your repaired OBJ file into the Upload window. Mixamo will verify the OBJ file is valid for rigging. If the OBJ file has no defects, this screen will come up. Click Next, then drag each of the circles onto your figure. Click Next, and your figure will spin around while Mixamo creates your rigging. When it finishes, it will create an animation showing the joints moving. If anything went wrong, the animation will look really bad, so if it looks okay, click on Next, then click on the Download button. It's normal that your figure only shows the top half. Download an FBX file and T-pose. Now we can open the FBX file in Blender. Once again, press AX Enter to clear the stage, then File, Import FBX. In the Import window, set the scale to 100, select your FBX file and click the Import button. You can see the figure now has rigging, the triangular overlays. In the upper right, click on Armature. Then, in the main menu, change the mode to Pose. For simple posing, you can click on a segment and press R. You must orient the figure to adjust how it will rotate the segment. Do one segment and click Enter to go on to the next. For more accurate posing, click on the small Item tab on the right of the viewport. If it isn't showing, click the tiny arrow in the upper right of the viewport. Now click on a segment and experiment with the X, Y, and Z sliders. Notice that you can manipulate even her finger joints. When you are satisfied with the pose, click File, Export, Wavefront, OBJ. If you keep the FBX file, you can easily reuse the figure to create different poses. Here is our figure in my slicer. You can see that the pose is what we expected, even the fingers. Here are a couple of prints in S-scale so you can compare the input files to the final prints. Sorry I can't help you paint all your great new figures, but maybe that technology will appear soon. I hope this video has given you a good start so you can experiment with the apps and start populating your railroad with lots of figures and small details.